We will be reviewing how variations of insolation affect how well solar panels work and how much electricity they produce. Insolation is the Earth's incoming solar radiation. Insolation is the main source of energy on our planet. It is responsible for the variations we have in temperature during different seasons and in different places on Earth. The amount of insolation an area receives depends on the specific latitude, season, and time of day. The intensity of insolation an area receives is dependent on the angle of insolation and the duration of that insolation. The angle of insolation is the angle the sun's rays make when they hit Earth's surface. The duration of insolation is the amount of time an area is receiving sunlight. If there is a more direct angle of insolation and if there are more hours of sunlight, then an area will receive more insolation. First, let's understand more about the angle of insolation. The sun is at its highest angle of 90 degrees, also known as the zenith angle, at the equator. At the equator, the sun's rays are perpendicular to the Earth's surface. The closer the angle of insolation is to 90 degrees, the more insolation there is. As you move away from the equator, the angle of insolation decreases. Therefore, the amount of insolation also decreases. Locations on or near the equator receive much more insolation than places like New York that are further away. Here we see this image showing that the angle of insolation at the equator is 90 degrees, the zenith angle, while in further places with latitudes of 60 degrees north, the angle of insolation is much lower, at about 30 degrees, meaning there is significantly less insolation here than at the equator. New York City has a latitude of 40.7 degrees north. Therefore, we have a lower angle of insolation because we are so far from the equator. The graph on the left shows how the amount of insolation varies as latitude changes. Note that the peak insolation occurs at the equator, which is at 0 degrees. The image on the right shows the same pattern. The most insolation occurs at or near the equator. As you move away from the equator, the amount of insolation decreases. Now we will learn about how the length of daylight affects the amount of insolation an area receives. The more hours of sunlight, the more insolation. The hours of sunlight varies depending on the seasons. Here in the northern hemisphere, we have more hours of sunlight in the summer and fewer in the winter. The image on the left shows how in the winter, Earth is tilted away from the sun, while in the summer, it is tilted towards the sun. Our winter solstice in this northern hemisphere occurs on December 21st. This day is the shortest day of the year, with the fewest hours of sunlight. The winter solstice marks the start of the winter season. On this day, the Earth is at its maximum tilt away from the sun. The summer solstice in the northern hemisphere occurs on June 21st. This marks the longest day of the year with the most hours of sunlight, and it is the start of the summer season. On this day, the Earth is at its maximum tilt towards the sun. Now that we know a bit more about insolation, we will learn how solar panels are affected by insolation. Solar panels use insolation to generate electricity. The more insolation, the more electricity a solar panel can produce. Optimizing the tilt or angle you install a solar panel at helps maximize electrical power production. As we have discussed, the latitude of a specific place and seasons are affected by insolation, which therefore impacts how well a solar panel functions. For us in New York, since we are at a latitude of 40.7 degrees north, we do not receive a direct angle of insolation. Our angle of insolation is much lower, so the amount of insolation we receive is lower as well. These two images show the difference in the angle of insolation for a place on the equator, like the city of Guayaquil in Ecuador, and a place with a higher latitude, like New York, that has a lower angle of insolation. Determining the optimum tilt to install solar panels is very important in order to produce the most electricity. Here in New York, we have seasons, so the optimal angle to install a solar panel actually changes for the summer and the winter. As the image here shows, during the summer, when the sun is higher in the sky, solar panels do not have to be tilted as much compared to the winter when they need to be tilted more to account for the sun being lower in the sky. There is an equation we can use to determine the best angle to install solar panels on our roofs. To determine the optimal angle in the winter, we take our latitude and add 15 degrees. In the summer, we actually subtract 15 degrees from our latitude. So knowing this equation and our latitude here in New York of 40.7 degrees north, what would be the optimal angle to install our panels in the winter? How about in the summer?